welcome back to our section on coordinate geometry proofs. We're looking at worksheet reteaching 6-7, and this is number 1 at the bottom of the worksheet. And we want to prove that the diagonals of a trapezoid are congruent. So for my picture here, I have all of my points listed, and this is directly from your worksheet. And we want to show the diagonals are congruent. So we're going to draw a dotted diagonal line here and a dotted diagonal line here. To make it a little bit easier, I'm going to label these points. I'm going to label this one A, B, C, and D, just so that we can label the lines with some letters. So we're going to be showing that AC and BD have the same length. And remember, length and distance are the same thing. When you're proving segments congruent, you want to use distance formula. So we're going to do distance formula. And first thing we want to do is write down our equation. And remember, distance is x2 minus x1 squared plus y2 minus y1 squared. Okay, now we want to start and first do the distance of AC. So the distance of AC, we're going to use both points A and point C to find our distance. So for the first one, we're going to have B minus negative A. Subtract your x's squared plus, then we subtract the y's, c minus 0, and then square that as well. Simplified, this will be the square root of b plus a squared plus c squared. And we don't need to simplify it any further because we do in fact know that with addition and different letters we cannot simplify any further. So now we're going to do the distance of BD. And again, we do y or x minus x first. So we're going to take A minus negative B. And remember, it doesn't matter which order you do your coordinates in, as long as you do it in the same way. So since I started with A here, I have to start with 0 on the second one. So this will be 0 minus c squared. Okay, so it doesn't matter if I do minus b minus a or a minus negative b, as long as for the next one I start with the same point. So our distance is equal to a plus b squared plus negative c squared. And remember, when we have a negative squared, it becomes positive. So this will become square root a plus b squared plus c squared. And because of the commutative property, you can switch addition so that it goes the other way. So we can switch this to b plus a squared plus c squared. And at this point, if we look at this row and this row, we have indeed proved that the diagonals are congruent. They have the same distance or the same length. So we can say so BD is congruent to AC. The diagonals are congruent. Okay, so that is our first proof from this worksheet. For the second one, we're going to actually look at number 2. Again, this is from Reteaching 6-7 worksheet. Okay, and we want to prove that the line containing the midpoint of the triangle, and if you remember from a couple sections back, that's known as a mid-segment. Okay, and we want to show that that's parallel to the third side. So the first thing we have to do, we look at our key words. So we want to know the midpoint of 2 of the sides. So we'll look at this side and this side, both at their midpoints. So first thing we have to use is midpoint formula. And then we want to show that they are parallel, and so parallel means we have to use slope formulas. So we're going to do midpoint first and then do some slopes. So remember, my midpoint formula is x1 plus x2 over 2, and then y1 plus y2 over 2. And that's a coordinate, x comma y. And notice that from the worksheet, I've changed this just a little bit. Anytime you see midpoints, it is easier to do them in multiples of 2. So instead of using B, C, and A 0, this is 0 down here, a 0, I multiplied everything by 2 just to make our life a little bit easier. We don't want to use fractions if we don't have to. So you can go ahead and change that on your worksheet, and we're going to go through it with the multiples of 2. For zeros, if you multiply 0 times 2, it's still 0, so we don't need to change that. Okay, so the first thing we want to do is to set up our equation for, we'll use this side first. We'll do this side here first, the one with 2b, 2c, and 2a. So we do x plus x, so 2b plus 2a over 2, comma. And then for our y's, 2c plus 0 over 2. I do want you to show all of your work so you don't make any silly mistakes. It's very easy to make small mistakes on these that lead to very wrong answers, and it makes your proofs difficult. So since these both have a 2, we can divide by 2. If only one of them had a 2, we would not be able to simplify it, so be very careful of that. And then for the other one, 2c over 2 will reduce to just c. So we have b plus a, oops, I forgot to get rid of my 2. That would be helpful. So if we take b plus a, 2b plus 2a, and divide it by 2, we should get regular b plus a because both of the 2's cancel. Sorry about that. There we go. So b plus a comma c would be your midpoint. So that would be right here. Okay, that's our midpoint of that segment. Now we have to do this segment over here and find the second midpoint. So we're going to do midpoint formula again. Okay, and again, x plus x, 2b plus 0 over 2, and y plus y, 2c plus 0 over 2. 2b over 2 will just be regular b, and 2c over 2 will just be regular c. So BC is the midpoint on this side. Okay. So our question is the line connecting those, this line right here, parallel to the third side, which is right here? So to do that, to see if it's parallel, we need to write two slope equations. So we're going to write our two slope equations. I'm going to do it right under my graph here. Remember, slope is y2 minus y1 over x2 minus x1. So our first slope, we'll do the mid segment first, okay, will be y minus y, c minus c, over b plus a minus b. And again, that was y minus y, x minus x on the bottom. This gives us a 0 on the top, and on the bottom we get a. But 0 over anything is just 0. So our slope is 0 for our mid-segment, which looks about right because it does look like a horizontal line. For our second one, we want to do y2 minus y1 again, over x2 minus x1. And when we plug in, we're again using this bottom line now, so we're going to do 2a minus 0, oops, sorry, y's first, 0 minus 0, over 2a minus 0, which is 0 over 2a, and that gives us a slope of 0. So we can say, therefore, the mid-segment is parallel to the third side because the slopes are equal. Remember, equal slopes mean that they are parallel. So that is our second proof. We proved that the mid-segment is parallel to the third side of a triangle. Okay. The next one we're going to do is number 3, and this is just a little bit longer of a proof. We're going to do number 3 on our worksheet, and we want to prove that the segments, all the segments joining the midpoints of a rectangle is a rhombus. So we have to find many midpoints, okay? And then once we found all our midpoints, we want to show that the inside shape is a rhombus. So we're going to find a midpoint here, 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 and here. You'll notice again that I did multiply all my coordinates by 2 since we're using midpoints, okay? And there's our keyword right there, the midpoints. We do want to make sure that we use multiples of 2. It will just make life much, much easier for us. So we're going to start finding our midpoints. So we'll start with the one at the top. We'll call these M, N, O, and P as our points. Okay, so we'll find M first. M would be x plus x, 2a plus 0 over 2, and then y plus y, 2b plus 2b over 2. And that will become 2a over 2, which is a, and 4b over 2, which is 2b. So that's our first midpoint. So this is a, 2b for m. So we're going to go to n and say n is equal to x plus x, 2a plus 2a over 2, y plus y, 2b plus 0 over 2, which gives us a result of 4a over 2. 4a over 2 is 2a, and 2b over 2, which is just b. So this is 2ab for n. Then we want to do O. For O, we want to use these two coordinates. So we have 2a plus 0 over 2, x plus x, 0 plus 0 over 2 for y, 0 plus 0. So we get for O, 2a over 2, which is a, and 0 over 2, which is 0. So O is a, 0. And then P is going to be 0 plus 0 over 2, add the x's, and then y plus y over 2, and that will give us a point of 0, 2b over 2 will become b. So this is 0b. Okay, so now it says we want to connect the midpoints. So those are all my orange points. I'm going to connect my midpoints, and I want to show that that orange shape is actually a rhombus. So remember, rhombuses have two pairs of parallel sides, and they also have equal sides. So we have to do all of our slopes. This is going to be like one of our former coordinate proofs where we do all our slopes, all our distances, and show what shape it is. So our goal is to show equal distances, 4 equal distances, and 2 pairs of parallel slopes. So we're going to start with slope of, let's do HN first. So that's this orange line right here. And remember, it's y minus y, 2b minus b over a minus 2a. So I get a result of b over negative a for HN. Next we'll do slope of, we'll just move around the circle, NO. So we do y minus y, b minus 0 over 2a minus a, which is going to be b over a. So we have some positive slopes there. Slope of, as we move around, OP will be next. Y minus y is going to be b minus 0 over x minus x, which will be 0 minus a, which is b over negative a again. And remember, for these slopes, it doesn't matter which x goes in front, as long as you put the same y in front. I always try to just make it so that I don't have as many negatives, because that just makes life a little easier. So the slope of PM is then going to be 2b minus b. Again, just because I know that 2b minus b will be positive, it makes life a little easier, and a minus 0, which is b over a. So I have indeed shown here that this line and this line are parallel, and this line and this line are parallel, because those pairs have the same slopes. So right at this point, I know it's a parallelogram, and I need to finish proving that it's a rhombus. So a rhombus is a parallelogram with all 4 sides the same. So we have to do our distances for that. So we're going to do distance of HN. And again, we're just going to start around the circle. So we're going to do equals square root x minus x, 2a minus a, squared, plus b minus 2b squared. So that'll give us a squared plus negative b squared, which is the same as a squared plus b squared. So there's our first distance completely simplified. After HN, we'll move around to NO. Okay, and NO has a result of 2a minus a squared plus b minus 0 squared. And we'll get square root a squared plus b squared. And that's kind of a little bit easier because you don't have that negative, so a squared plus b squared. So far we do know that HN and NO are the same. And we have to continue on showing that OP and PM are the same. So I'm going to move over here to do the distance of OP. Okay, and I'm going to do, again, a minus 0 squared, subtract your x's, then subtract your y's. Make sure they go in the same order. This will be a squared plus negative b squared, which is the same as a squared plus b squared. Okay, so we do have OP also congruent now. And the last one, our last one is going to be the distance of PM to finish it up all the way around, and we have PM is a minus 0 squared plus 2b minus b squared, which gives me a result of a squared plus b squared, both positive. So I do in fact know that it is a rhombus. I've proved that because I have 4 congruent sides and 2 pairs of parallel segments. Okay, so that's a complete coordinate proof showing that if I count all of the midpoints of my rectangle, connect them up, I get a nice rhombus. Okay, and that's actually true of all quadrilaterals, which you'll be looking at on some other proofs on your homework. So I'll do another video that'll have a couple more of these just so you can get some more practice with them. But that'll be the end of this video for now. These are just some examples to help you get started on your homework.